By now you're getting very comfortable with the gate instantiation syntax. For example, if we wanted to create an AND gate, we could write code that looks like this. But what if we wanted to do a more complicated expression? For example, x equals A and B or not C and D. We could write the following code using the Verilog that you already know. The good thing about this implementation is that it's very clear that we're describing hardware and exactly what the gates are. The bad thing is that it's very much more verbose than the Boolean expression. Verilog also allows us to describe hardware using Boolean expressions directly. For example, we could write code that looks like this. This code is much more concise and is entirely equivalent to the above. This expression is also describing a series of gates. It's important that you don't think about this as software, as you'll just confuse yourself. Note that much like in C, we're using the single ampersand as a bitwise AND, a vertical bar as a bitwise OR, and a tilde symbol for a bitwise NOT. You can also use the exclamation point, also known as a bang, for a NOT that works for 1-bit signals. For this lab, we're providing a parameterized register library whose interface looks like this. Most of this interface is straightforward and should be recognizable, but the parameter keyword is new. Parameter provides a means for compile time specialization. In this case, the width of the register can be set when you instantiate the register. For example, if I wanted to create an 8-bit register, I could write the following. The number sign 8 specifies that the first parameter should be set to 8, which in turn sets the width of the output and input signals for the register. Pretty cool, huh?